talk about lectures, I'll try to be close to this microphone. Yeah. So in the last lecture, we have given quite a few examples showing how machine learning, how popular machine learning is, and how successful machine learning is, and how it is related to our daily lives, and also we discuss and give a formal definition of machine learning, and hopefully that kind of introduction can attract you enough to stick to the whole semester. But in the meantime, I want to stress on the challenge of this course. Again, I'm sorry. So first of all, I mean, according to my past experience, many students complain this course is quite hard. And if you want to get high grade, you need to spend enough time, which from their words like on average 20 hours per week. But I believe for many of you who is very smart, who has enough foundations, 20 hours might be too long. You might spend like 5 hours or 10 hours. Sufficient for you to do everything. But I just talk about average and worst cases. So think of it early. So if you haven't started homework 0, I would suggest to start it right now, so that you can, throughout these review assignments, you can make some kind of self-evaluation, say if it is the right time for you to register for this class now, or you want to join later, or you don't want to join anymore. But anyway, I just suggest you to think carefully. And today we're gonna spend most of the lecture time talking about the syllabus, logistics, course schedule, and requirement, grading policy, all kinds of stuff. So please bear with me. I spent seemingly quite a long time talking about this, but I just want to give you the details about this class, especially what kind of expectation for you to do this class, and so that you have a sufficient basis which you can make decision. That's it. And another thing I want to mention is that some students asked me after last lecture, said if I happen to have something else to do and cannot attend lecture, will there be any Zoom link or lecture videos? But honestly, I don't have Zoom link because I was required to teach in person, and at the main department doesn't like offer us the environment to do the Zoom live and in-person teaching. But we have this streaming camera, and we have already been successfully set it up. That means the lectures will be streamed to a YouTube channel, which is called UFU Data Science. You don't need to memorize this channel. I will release the lecture video, the link to the lecture video in the course web page after every class. So if you happen to have some other things to do and cannot join the lecture, you can watch the video online. But again, I highly recommend you guys to join the lecture in person and interact with the instructor. That will be the most efficient and effective way to learn something, rather than just watch the video for 100 times and you didn't get what's the key point? Is I think that's better for you to for the learning efficiency. And okay, so let's talk about the syllabus. So you can see that this is a course web page. Again, you don't need to memorize this link. And if you want to access the course web page, you can just go to my homepage. And it's very easy to go to my homepage. You just search my name on Google. That's the first entry, I believe, will be my homepage. And I think I haven't shown, I haven't shown this to you at the end of last lecture, but let me click the link again. Oh, sorry. Why it doesn't jump to the link? Click this again. All right, here we go. Okay. Yeah, this is me, and from this home page, you can just scroll down and find the teaching section, and click this link. This is our class, and when we click into this, this is the whole course web page. You can see that we have quite a few sections. Home introduces general information of this course, and the information provides a full list, a quite comprehensive list of references. Some of you have asked if I want to review some basic knowledge, what kind of materials should I use, or if I want to know more in depth, deeper than what we have discussed in the class, what kind of book textbooks I can look. They are all contained here, and I will give a brief introduction later, and topics. And here our tentative schedule of the class content, and which we're gonna discuss later. And this one, perhaps is the most commonly, the most popular entry you're gonna access from this website is the lecture schedule. So you see that I will usually post the lecture slides before the class. It's not necessary to be right before, maybe just the one day before. And then after the class, once the video has been uploaded to the YouTube channel, I will give the link of the video here. I'm sorry, Monday, because of the device issue and account issue, we're not able to make this streaming device work. So I just put a link of the lecture made, I guess 2 years ago. Oh no, 1 year ago, last year. But the first two lectures, they're quite overlapping, so you don't miss anything. And again, after today's lecture, I'm gonna put a video link here. So if you want to watch them again, you can click into that. And also here, I'll post just the time when we release the homework and what to do. But of course, all this information are published is published in the Canvas, and this is just to give you a multi-source of information for reminder. Okay, so let me go back to the home page of the course web page, right? Course website. So this is schedule. Hopefully, let me enlarge the font. Yeah, and I believe everyone knows that. But if you're not sure, someday early morning you suddenly forget where to go to this class, and just look at this course web page and the time. I also final exam. I just paste the final exam from the official schedule page from the school or university. It's on December 15th from 8 to 10 a.m. Wow, it's quite early time. And in this particular class, we're going to do the in-person exam. And if you want to further confirm, you can click in this official page. They have given the rule. They have given a rule how to schedule the final exam. I believe everyone is familiar with that. And this is me and the instructor. If you click this and go back to my home page, and let me go back to the course web page. So this is my office, and this is supposed to be the place where I do the office hour. But unfortunately, due to the damage of my office and still yet fixed, so I can only do the Zoom office hour right now. But good thing is that we have managed to get TA office for office hours. So we have 4 teaching assistants, Shikai Fang and Shibo Li, Michael Pan Walden, and Ashish coffee party here. So we have 4 very good teaching assistants to help you, and we schedule office hour every weekday. I mean Monday, Tuesday, Wednesday, Thursday, and Friday. Every day we have an office hour. So you can see the office hour schedule here. My office hour is on the day of the classes, day of lectures, like namely Tuesday and Thursday, from 2 p.m. to 3:10 p.m. And it's supposed to be in my office, but right now, again, I mean, it has to be in Zoom. But for the teaching assistants, we have got the teacher offices, so you can come to the office in person and talk to them and ask questions and so on. Right? So on Monday it will be 1 to 3 p.m. Led by Michael Panwarden, and Wednesday will be Shibo Lee, 3 to 5 p.m. in this map building 3115. Oh, Monday is 2 to 5, and on Friday we actually have 2 office hours. One is from Sish. He's gonna take 1 to 2 p.m. on map 3159, and then Shikai Fang from Friday 3 to 5 p.m. in map 3115. I'm sorry, those 2 offices are not the same. The reason is simply because the shortage of these offices, and we have tried very hard to got those rooms, but you can see that, I mean, on Friday we have 3 hours in total office hours. The reason is just because most of the homework deadlines will be on Friday. So if you really want some help on Friday, I mean, when approaching deadline, we try to allocate more time for you. And if you happen to, I mean, it's quite rare. If you happen to be unable to attend any office hour in any of those office hours from Monday to Friday, you can try to, I mean, send an email to me or send an email to any teaching assistant to schedule an extra time, and we'll see that. But hopefully that will be just occasionally, not I mean, allocate a specific time just for you. That usually won't work. Okay, so now we'll talk about details about this course web page later. We'll first look at the syllabus because it contains the most important information about this course. Again, in the syllabus. Oh, by the way, the syllabus and the course web page are all the link are all released in the Canvas. So if you go to the Canvas class and click the syllabus, you will see those links. So you have multi-entries to access those documents, and hopefully that will make you feel better, make you feel more convenient. So course page here, and teaching mentee list, office hours, those are redundant information. So description, I just read this to give you a sense what is the high-level expectation and high-level content of this course. So our course introduces basic knowledge of machine learning. So topics contain several fundamental and widely successful supervised learning and unsupervised learning algorithms, from the most intuitive decision trees to more state-of-art artificial neural nets, and also very classical topic, kernel methods, support vector machines, and probabilistic methods. Right? So after taking this class, we hope that you will first you will understand the machine learning ideas and paradigms. That might differ from your other, I mean, if you're from other disciplines, that might differ the way you think of modern problems. And second, you will be able to identify, identify appropriate machine learning problems for your own research or applications. So let me make it larger. That means you will be able to know which kind of problems or sense which kind of problems might be solvable by machine learning techniques. That is really important. Although machine learning is popular, that does not mean machine learning can solve everything. Right? You need to know which problems is worth machine learning and which problems are not. And third, you'll be able to design machine learning models and to implement learning algorithms. Of course, with appropriate tools if necessary. You don't need to implement every algorithm from scratch, but at least you should be confident to select existing algorithms or do some modification on the existing algorithms to address your own problem. Okay? So that's the high-level description of this course, and hopefully that gives you kind of impression, a sense. And then books, right? So this is some frequent asked question. So there's no designated textbook for this course. The reason is just want to reduce your load. If I give you a book and you see that all the popular or classical machine learning book is thick like this, right? So it contains too much chapters, too many algorithm models. I don't think it's necessary for you to go through a thick book. Instead, we'll put everything in the lecture slides. So lecture slides are self-contained. I mean, to deal with the project, to deal with your homework assignments or final exam, lecture slides are enough. But of course, if you want more in-depth introduction or more comprehensive introduction about machine learning model and algorithms, you're welcome to look at the popular machine learning books, like this one, written by Kevin Murphy. Machine probabilistic perspective is very, very thick. It's about like 1,200 pages. And this is some kind of old book. It's also very thick. It's pattern recognition machine learning. That is what I learned machine learning by myself about 10 years ago. And this one, causing machine learning. This is some kind of assembly of the lecture slides from Hao Daoming. And it's pretty good. If you're interested, you can take a look. And this one, written by 3 Stanford statisticians, they talk about the elements of statistical learning. But purely from a statistical point of view, it's not very appropriate from my own point of view. For if your background is only from engineering, it's not very easy to read. But if your background from pure statistics, it might taste good. And this is a very classical one: information theory, inference, and learning algorithm. David Kai has passed away several years ago. Is a genius guy. But this book is very fundamental. It connects information theory, probabilistic learning, and probabilistic inference. Of course, it worth reading if you have enough time. Okay, these are about prerequisites. Right? So I think I don't need to read through them because you guys all know the prerequisites. But what does this list of courses in the prerequisite imply? So implies that you should know basic probability theory and statistics. I believe in our homework 0 covers such kind of problems. And secondly, you're familiar with linear algebra, vector and matrix derivatives, and in our homework 0 we cover some kind of linear algebra, and also ask you to calculate simple vector derivatives. Hopefully, you won't feel like very uncomfortable with that, or even get irritated. Otherwise, it might be problematic for the following topics we're going to discuss. And the third one, we assume that you have algorithm design, programming, and debugging skills. This is very important because again, I mean, let me emphasize again, and bear with me. This course is not just literally say what model is this, what kind of models are and algorithm steps you need to implement by yourself. And it's different. It might be different from like programming course, like say in computer science department, because you need to implement some numerical operations in your algorithm steps. And the debugging is also kind of obstructive in that you will look at, okay, what is the numpy arrays, numpy arrays, and what is the vectors? Do their values look good? And should I go back and do it step by step? So that doesn't mean it's very hard. That just means you need to have this basic programming debugging skills. Otherwise, it will be really painful. So yeah, I believe everyone has had such kind of issue, but let me stress on that and to remind you, our class, the practice in our class is very, very important. Okay, so now come to the very important part, getting help. Right? So, sorry. Okay, so we're trying our best to offer the help to serve everyone. But meanwhile, I really suggest you guys to take advantage of the office hours. As we mentioned, right, we have the office hour every weekday. So don't be shy. If you have any problem, any concerns about this class, homework assignments, projects, project report, and even project selection, just come and ask and talk to me or our TMs. They will do their best to help you and to help solve those problems. And if you cannot come to the office hours, you can send emails or speak up in the class. Right? So, in addition, we use Canvas QA. So Canvas, I believe everybody is familiar with that. They have some kind of online forum, so feel free to post questions. Our TMs are watching the Canvas every day. They will try to respond to your questions as soon as they can. But one thing, do not post potential answers for the homework assignments. That's the red line. I mean, yeah, it's good for you to discuss what's the meaning for this problem and what is the expectation of this problem, or clarify a few things. But you shouldn't ask. But you should ask, how should I solve this problem? Okay. And if somebody asks that, no one is allowed to say, okay, I believe the first step is to derive this, and the second step is to derive that, blah, blah, blah. If something that happens, we're going to just delete that answer. Does it sound good? Okay. And also, we will make important announcements in Canvas. So I guess Canvas will send you the notification emails, right? So just watch those emails, like when we release homework, we release some change. It might be, I mean, occasionally there might be some change of the schedule or whatever. Just watch the Canvas. Of course, for some important notices, I will send quite a few times. For example, final exam. Final exam, I usually send 3 reminders to when the end of the semester approaches, and to ensure no one just escapes or forget the final exam. Okay. Any question regarding this topic, like how to get help? Okay. Yeah, I'm glad that it sounds it makes sense to everyone, and I'm really hopeful. I really hope that everyone could effectively and efficiently leverage the office hours, because it indeed helps. That's from the feedback from my previous students. So if you feel like stressful, if you're not confident about this class, you can come to the office hour and talk to me, and let me give you some suggestions. So don't be shy, and don't feel like don't freak out. I mean, I got some experience before. Some students they feel difficult and feel challenging, and don't know how to solve that, and didn't come to me, and kind of almost freak out. When the semester comes by, when the semester goes by, and finally he dropped that class. But he had to get some signature from the dean. That's not very good, and I don't want anyone to feel frustrated about this class. But I need to emphasize. There's no free lunch. You're interested in this. You need to spend efforts on that. Okay, so don't be shy, and we come to the office hour and seek for help. Okay, and then this is about the tentative course outline, and so the most important topic will be the supervised machine learning, and we will study supervised machine learning throughout several very popular, fundamental, and important machine learning models and algorithms. Now include and throughout discussion of those models and algorithms, we'll know some basic ideas and strategies in designing machine learning methods. Like we'll start with decision trees, and why? Because it's so close to human intuition. Like when human beings make decisions, it's like psychologists have proved that it has kind of like tree structure. And the decision tree is just automatic way to construct rules from data in its hierarchical structure. And then by applying decision trees to practical problems, we'll find some fundamental issues in machine learning practice. Overfitting. How do I avoid overfitting? That is an important question. That's actually how the frontier research try to make the learning models better, right? So, the most commonly used strategy is called cross-validation, and we'll talk about that later. And then we'll talk about Bayesian ensemble learning. Maybe 20 years ago, it's kind of a revolutionary idea. Like how do you combine a set of very weak classifiers, and if you can smartly combine them, it can outperform a strong classifier. And many applications using that, like the digital camera. Then when they found the bounding box of pieces, they're implemented by the Syllabus algorithm. And then we'll talk about linear regression and least mean square approach. This sounds very familiar to you guys who have taken the statistics class before. But we'll talk about from linear regression. We'll talk about what is loss function, what does it mean, what is cost function or loss function, and what does least square mean, and we'll talk about how to calculate the gradient, and also how to calculate the stochastic gradient. And then we'll talk about linear classifier. And although this sounds kind of straightforward, but it is a foundation for many more powerful nonlinear classifiers. Right, we'll start with this classical perception algorithm, and then we'll move to the support vector machines. So you see as support vector machines, why it's so elegant and so powerful, because it is directly justified by computational learning theory, and it connects to the upper bound of the generalization error to the maximal larging, and then how to maximize the larging, and we have a set of very smart optimization tricks to do that, and you will get to know a few key principles in optimization world, even you haven't heard them before, like KKT conditions, like and primal and dual problem. Don't worry, I don't need you guys to be expert in optimization. as long as you have the basic foundations and calculus, that won't be hard to understand. But through learning of the support vector machines, you'll get to know many key concepts in optimization that is very beneficial for your future study. And then we'll talk about some probabilistic learning concepts with two typical examples. One is called naive Bayes. Sorry. What happens? All right. And the other is called logistic regression. Although these two are both linear classifiers, they are used very, very widely in practice. Like logistic regression is kind of like all the online advertising platforms, they use logistic regression to predict the click-through rate, namely how likely you're gonna click this advertisement. They based on their prediction, they're gonna decide which kind of advertisement will be pushed in front of you. And then we'll switch to nonlinear classifiers. Nearest neighbor classifiers, it is one, but its essence. I mean, the algorithm is very, very easy, very, very intuitive, but the essence is not that easy. You see a VC dimension, which measures the capability of nearest neighbor classifiers, is infinite. And kernel tricks, that's I think one of the most important computational tricks used in machine learning is called kernel tricks. By using kernel tricks, we can easily extend a linear classifier to a nonlinear classifier in a very elegant way. And we'll see how we extend perceptron to its nonlinear version by introducing kernels and nonlinear SVM. And only when we talk about nonlinear SVM or kernel SVM, we get to know why it is called SVM. Otherwise, you feel like very confused. Where does the support vectors come from? And of course, we won't forget the hottest area, right? Deep neural nets. I guess most of you might favor this most. We'll spend quite a few lectures talking about deep neural nets, and especially how it works, and how it is trained, and especially what's the mechanism of backpropagation. You'll see that it's just a simple application of the chain rule. But it's very smart application of chain rule. And everyone will need to calculate backpropagation on paper and implement backpropagation by yourself. And you're gonna implement your own deep neural nets, implement backpropagation for training, and test it on real data sets to show your algorithm works. And unsupervised learning, if we have time, if we have time, we'll introduce the classical k-means clustering and variance and Gaussian mixture models. But even we don't have time to cover it, don't worry, because the most important part is the supervised learning. Once you know all this about supervised learning, it's very easy to adapt to unsupervised learning. So don't worry too much about that. And finally, we're going to give some practical guidance about machine learning. And we're going to invite our 1 TM or 2 TMs to give the brief introduction of the state-of-art machine learning libraries like PyTorch and TensorFlow. Our past experience shows that this kind of tutorial is very, very popular. So I suggest you guys to join the lecture and try their examples and have fun, and by using PyTorch or TensorFlow. And we'll give some empirical suggestions, like if you want to apply machine learning in your job, in your work, how should it be integrated with the other components in your system, or in a system, and how do you develop machine learning models and algorithms? It's not like you do it in a very refined way. Instead, you should do it in a fast, iterative way. That is most practical way. Okay, any question regarding the course content? Yeah, so although it looks like it's not too much topic, but it's but it's quite much actually, and the pace will be quite fast. And we'll see later. Yeah. So grading policy. Our grading, final grade, is determined by 3 components. First is the homeworks, second is course project, and third is final exam. So first, we don't have midterm exam. I don't think some kind of, paper exams really matter very much. I'm more interested in whether you really understand these basic concepts and ideas, and whether you are able to apply those methods and models to address the problem. That's why we put the most important part as the homeworks. Take 50%. We have 6 homeworks, and except the very first homework 0, all the other homeworks we have both the written part and the programming part. So the written part, just to verify your understanding of those basic concepts or computational procedures in algorithms. So if you feel some kind of paper problems are really tedious, just be patient. This is just to make sure that you understand every detail of the algorithm before you start to implement those algorithms. So I'm saying such kind of complaint, but if you feel like you are very, very smart, you don't need such kind of things, just let me know. We can discuss about that. Right? So, and then in addition to the written problem, the program's assignments is very, very, very important. So basically, every model and algorithm we discuss in class, you're gonna implement one by yourself. And how to implement them? Which programming language you should use to implement them? We highly recommend Python, MATLAB, or R, because these are the most popular programming language used by machine learning community, especially Python. It's kind of dominant. And the Python, another benefit of Python is that it has many libraries, and you don't need to know too much about low-level details. Like if you use C and C++, you're going to be confused by pointers, references, and pointer to pointers, all kinds of stuff. I don't want you to stuck in those details. Just focus on models and algorithms. But if you insist on that, you're going to use other programming language like Java or C++, it's doable. You just need to make sure that your algorithm, your implementation can be compiled and run on the paid machines, because our TMs, we're going to grade your implementation on paid machines. And we're not just look at the code, the source code, we're going to test the code to make sure that they're runnable on those machines. And also, when you implement those machine learning models, algorithm, feel free to use existing libraries, like numerical libraries like NumPy, SciPy, Python, or MATLAB. They have many functions to implement all kinds of matrix computations. And also optimization packages like LPFTS. But the problem is that you can never call some API which directly implements the required model algorithm. Like you know that in Python there's a library called scikit-learn, implements a variety of machine learning models and algorithms, including decision trees, including SVM, including blah blah blah. You can now just call one line of API, like create a decision tree. You finish the create a decision tree. This is not allowed. Okay, machines are just the machines on those labs. In web building, map building, ECE and CS department, there are many labs, and the machines are there. So basically, they install like most commonly used libraries. But I'm not sure if you're using other language like Julia or other if they support it now. That's why I suggest. If you use Python, I don't think you need to worry about that. But if you use other, third-party language, you need to ensure that they are runnable on K machines. Otherwise, our TMs cannot read. Any other question?
Will you be running and compiling them through the command line?
Running what?
Will you be running and compiling them, like testing them through the command line?
Yeah. I mean, if you use C++, but you need to give us the command line to compile that. Like if you use GCC, right? If you use GCC or G++, just leave one line of the command to compile your source code in the README, and then our TMs or TAs can compile it and run. Any other question? Okay, great. So again, that's very important, debugging and programming. So we trust everybody has the capability to implement those algorithms. I trust you can debug it. So we usually cannot debug it for you. Right? If you bring your laptop and ask your TM to sit down and debug it for you, that's not allowed. You can see that, okay, I try very hard and try to debug it 100 times and still cannot find a problem. Can you give me some hint? That's okay. But you cannot sit in front of a TM, like let him debug the code for you. That's not the purpose of this class. Does it sound good? Okay. And okay, so these are about homeworks. And again, I suggest you to do homework as early as possible. The workload here is pretty heavy. I mean, if you start early, the time is pretty sufficient. But if you want to do it on last day, see, Friday, even you have 3 hours for the office hour for the help, that won't be enough. So again, I mean, I will keep reminding you to every time when the new homework is released, I'll keep reminding you to do it early. But again, don't try to catch it at the last minute. And course project. And we're going to do a course project to give you a sense how machine learning can be applied to real problems. And we're going to require you to create a GitHub repository to record the progress, the source code, the documentation. Of course, this GitHub repository should be private and should only be accessible by you and our TMs, and do not release or publish them before the end of semester. And also, you see that for the homework assignments, you see that instructions about the GitHub as well. And at the end of the semester, basically, after each homework, we hope you can push some of your implementation into the GitHub repository. And at the end of the semester, you will see that you have already successfully built a tiny machine learning library. That is actually indicates your achievement of this class. Okay. And what kind of course project? Right? So the details are given in the course webpage. You can see the projects item here. Right? So so basically, you can choose 2 types of projects. One is called a competitive project. The other is called exploratory project. So what is competitive project? It's just a Kaggle competition task. How many of you have heard Kaggle? Okay, great. So Kaggle essentially is a data science platform. It released a lot of data, real-world data, and the tasks. They're going to give you some tasks. They have their training data and they have task data, and they encourage you to submit your solution to their platform so that they can evaluate the quality of the platform and give you a score or rank your solution. Compare with all the others. So if you choose to do a competitive project, you're gonna do this by yourself. There's no team. Right? You do this solo competitive project, and we're gonna open a Kaggle competition task, just for our own class. You're gonna do that, and you're gonna submit your solution, and you're gonna say what is the performance of your solution, and you see some ranking board, and what is your rank, and if you rank, say, top 5, you're going to have an extra bonus. And another type of a project is called exploratory project. So, exploratory project, as the name suggested, you are freely to use machine learning techniques to address any problem you want to address. Like, for example, if you're doing some research in a mechanical lab or in other labs, you feel like, okay, this particular problem might worth machine learning techniques, and you can try that. And then you're gonna write some report, and report what's the effect of machine learning, what's the problem, and do you think it's successful or not? If it is not successful, what's the problem, and so on. So the project, the report of the exploratory project looks like a small paper. But the exploratory project, you can form a team of at most 2 people. So before I confirm with you if you are comfortable with these choices, let me briefly introduce the grading milestones. Right? So no matter which type of projects you're choosing, you need to create a GitHub repository and update and maintain your project. And because the project is done, throughout this semester, we have several milestones. So first, you need to indicate which type of project you want. And if you're doing Explorer project, what is your project team membership? Just to let us know. We'll soon release the deadline for this. But right now, I think you can start to make decisions and choose for a potential teammate. And then project proposal. If you're doing competitive project, then you need to register for the category competition. And then make some dummy submission, meaning that, okay, you know the whole procedure to submit a solution to that platform. And also you submit your category users, sorry, it's not on Piazza, it's on Canvas, and we'll correct it later. And so that we can track your identity. And we know that who is that username. And if you're doing Explorer project, just to submit one-page document, briefly telling us who are the team members, what problem do you want to address, and why you think it is interesting and worth machine learning techniques. And just answer the 3 questions here. Are you fine? And this should be done in the quite early, I guess 2 or 3 weeks. And then in the midterm, although we don't have midterm exam, but we do need a midterm report. Namely, what's the current status about your project, category competition or the Explorer project. Right? So if you're doing competitive project, you should have made at least 2 non-dummy submissions. Non-dummy submissions mean that you have tried twice to solve that problem. No matter how naive the methods look like, but you have to try at least twice. And your report about that competitive project should describe what you have done and any pre-processing you need to do, and outline your plan for the rest of the semester. Right? What kind of techniques you're going to use in the remaining half of the semester, and what kind of improvement you expect to have. And of course, and then here is the bonus. Right? If you by the deadline of the midterm report, not including the late dates, right? The top 10 ranked students will receive 3 bonus points. And for the Explorer project, your report should include what you have done to reach your goal, right? Not just I have collected data from a device, right? And you should say, okay, I have tried some algorithms, like simple algorithms, like decision trees, or linear regressions, and I'm tested. I've known if it works better than the traditional methods. And what is the detailed plan for the rest of the project, right? What kind of improvement you want to make, not only in more complex models algorithm, but also in like more refined pre-processing steps and experimental design. All these are good, right? And also reference to literature. And then at the end of the semester, everyone should submit the final report. And the final report is up to 6 pages in size 11 fonts, so don't submit very lengthy report, 10 pages long. That's not necessary, and don't spend too much time on that. Just to be concise, hit the point. So this report should be structured as a small research paper, and consists of following content. First, problem definition and motivation. So what problem did you choose, right? If you're doing Kaggle computation, of course, from Kaggle computation introduction, you can easily formulate a problem. If you're doing Explorers project, you need to formulate your problem. That is quite unique. Right? And why it is important and interesting, and why do you use machine learning techniques to solve it? Well, this is mainly regarding the exploratory project. And second is about the solution, right? Your methods. What is the details about machine learning techniques you have used, right? And what are the experimental results, right? And if these experimental results look good, what's the reason? If it's look bad, what's the reason? What is the expectation to further improve this, right? And finally, something about the future work. Of course, I guess most of you won't do the future work about that, but as a scientific custom or scientific it's kind of like by default you should talk about some future work along that, so that will allow people to follow up your work. And someone may choose to do the theoretical project. If you want to prove something, you want to show some computational learning theory. That's great. That means you don't need to do some experimental evaluation. And then we will put the solution experimental evaluation as one component with 40 points. Okay. And again, the final report must include a GitHub repository links to your implementation of the project. We'll check the implementations as well, and this is very important. We don't want to just leave a PDF report and nothing else. I want you really to do something in your project. Okay, any question regarding the project?
So I'm not familiar with Kaggle, but what you're saying is that on Kaggle there are like problems to be solved, and you just pick one and work with their data.
Yes. Yes. Yeah, but if you do the competitive project, the Kaggle computation will run by me. There is an in-class Kaggle computation. It's private. It's not public. But I mean, if you want to do the Explorer project, you can choose Kaggle tab as well. Right? That's it's still up to you. Other question?
Yeah, we can use APIs for the project, right? Like scikit-learn, and for the project we can use, or we can only use the algorithms that we have written ourselves.
Yeah. You can use whatever algorithm. You don't need. I mean, for the project, you don't need to implement those models by yourself. You can use whatever open source library to do that. The goal of this project is to give you a sense how to apply machine learning to address practical problems. So you don't need to implement those models algorithms by yourself.
Do you know what the in-class, or what the Kaggle competition is going to be about, the competitive one this semester?
Yeah, it's a prediction task. I'll give you some information. I guess it's from banks information, like customers, and you're gonna predict if the income of these customers is high enough or not high enough to give a loan, such kind of things. And we will release the Kaggle computation link very soon. Yeah. Any other question? Okay, great. So So here is just a list of topics for exploring projects, right? So of course, if you are looking for ideas of possible projects, right, you are not sure about that, you can come to the office hours and talk to me. I can give you some suggestions. I've helped quite a few students in the past. Like you can do some application project, find some problem you feel interesting. You can reproduce some published results, like you read some machine learning papers and you found it's very interesting. You want to implement by yourself and reproduce the results. You can even do a directed project if you're confident about that. You can do some algorithm project, like you want to develop new learning algorithms. But honestly, if you were able to do that, it's very good. It's very good. We don't expect this class the students can do some research on machine learning, and also your own research means you want to apply machine learning techniques to address your research problems. I've seen students who have done this before. They do some physical simulation about reservoir, and they use machine learning techniques to replace the expensive numerical solvers. That's very interesting. And if you want to find exploratory project examples, as I just said, right, you can take a look the Kaggle computation platforms. If you take a look, you'll see that there are many problems. Many problems. Okay. Click any one of them, you will see the task definition, the data, and the snippet of the data, and how you submit the solution. And if you attend their computation, you will see the ranking. Some kind of computation even can give you some reward if you can be ranked as top. Okay. And other commonly seen exploratory examples, including like biological and medical study, like select genes relevant to cancers, learning to play ball games like checkers, setters of content, and etc., and predict stock market. But I would suggest not to do this because usually this always failed. And many students did this before, but they just failed. Like, it's very hard. Yeah, and detecting humor, ironic metaphor in text is called sentimental analysis. If you're working on text mining and natural language processing, that would be an interesting topic. Classically run of song, book, movie, painting. Recommendation, there are many recommendation data set. Software security, and can you classify malicious, can you identify malicious malwares, iPhone, Android apps, and spam emails detection. I mean, this one is a little bit easier. When we talk about, after we talk about the IPs, you can implement it by yourself. All right, those are about the project. I mean, again, we will give a rough look at those requirements of class projects, but I will highly recommend you guys to look into the details later so that you can better make a decision. And then let's go back. Yeah, and final exam. Those are about class project. And final exam. Final exam is open book. I don't require anyone to memorize the formulas and theorems, derivations, all kinds of stuff. It's not required. You can bring whatever materials you think will help the exam, but you cannot bring computers. You cannot bring cell phones, tablets. The reason is that I don't want anyone who posts the questions on like Stack Overflow or whatever, or what else, whatever platforms to wait for answers from others. You can print out lecture slides, you can print out homework assignments, whatever you feel helpful, just bring to a final exam. Okay, letter grade method. So, this is a mixture class. I mixed of undergrad, senior grad undergrad level and grad level class. So that means we have different requirements for undergrad and grad students. We won't curve the grade. but we have different letter mapping. So you see that for undergrad students, I expect it is easier to get A. This is the range, right? If you get 88 to 100, you're gonna letter A grade final, and 82 to 87 A minus, and so on. And for graduate student, your bar is a little bit higher. You need to get 91 to 100 numerical grade to get final letter A, right? 85 to 90 A minus, 79 to 84 B plus, and so on. And someone asked, what if I got 85.6, right? We just do a run up, right? And like 90, like 90.5 to 90.9 will be treated as 91, and otherwise it's truncated to 90, right? So some of you might be very careful, sensitive to this letter grade, and if such kind of grade is released, and you feel like you won't get a higher grade, you feel like you should have higher grade, and you can contact me, and we'll just pull out all of your homework assignments, homework submissions, and reports, and final exam, and see if we can find a little bit more grade to increase that. But if we cannot, then we just use the original. You're where you are, okay? Okay, again, final exam, right? It's here, right? And I will send you several reminders when the end of semester is approaching, right? So late policy, that's very important. Okay? I don't want you guys to lose credits due to the lateness, right? So each assignment will be turned through cameras, but the designated deadline is usually midnight, right? 11:59 p.m. to receive full credit. If you pass the deadline, you get 10% penalty. But if by the time you have passed matters as well. So if you pass deadline like over 24 hours, first 24 hours, you get another 10% penalty, right? If the assignment has 10 points and you submitted this assignment 30 hours later, like you first incur a penalty of lateness 10%, and then incur another penalty of 24 hours, another 10%. So you lose 2 points. And if you return, like if you submitted homework assignments like 48 hours later than 48 hours, then 0 grade. So it's kind of quite rigid, and so that's why I encourage everyone to start doing the homework early, as soon as possible. Don't rush at the last minute, and usually the time won't be enough. Any question? Okay, great. So we should allocate enough time for you to do this assignments. So usually we don't make exceptions if you get some cold. But if you have some prolonged illness, just give me the doctor's note. We can consider the extension. And if you have some emergency, right, so that you miss the deadline, just let me know. And then you need to give me some document, for example, 911 or some emergency. You get some witness signature, whatever. But you need to contact me in time. Okay? Otherwise, you just get your grades deducted. And if you believe there is an error in grading homeworks, right, you may request a regrading within 1 week of receiving your grade. So don't assume that our TM's grade is perfect. they can make mistakes as well. So if you feel, okay, this doesn't make any sense, give a solo grade, let us know as soon as possible. Okay. I remember last semester, like one student came to me like at near the end of semester talking about their homework 2 or homework 3. There's some error in the grading. Well, that's not good. Right? You should watch your grade, right? So just if you feel not right about your grading, just contact us as soon as possible so we can regrade. Okay. And homework submission. We only accept homeworks written with LaTeX. So LaTeX is kind of like a standard, factual standard in scientific community, scientific and engineering community. And so basically you write everything, math, formulas in their script language, and they compile to give a very beautiful and elegant PDF, and we'll just look at that. We don't accept the manual written things because it's really unclear. And don't be scared of the LaTeX. It's very easy to use. And here we give a link of the examples. Right? So it's from my colleague Jeff. He gives some excellent template of LaTeX. And also when we release the homework, maybe you have seen that the LaTeX source is attached there. You just follow the symbols are written there. You just write down your own solutions. That should be more than enough. And what you need to do is just to find some LaTeX IDE, like LaTeX Studio, LaTeX Shop, Text Shop, Text Studio, whatever. There are many. Just use them and compile them and submit PDF. Okay. And attending final exam, I don't want everyone to miss the final exam, but maybe you have some emergency, and maybe you have some conflict of schedule. I mean, abrupt conflict, whatever. Please let me know beforehand. But if it is due to some emergency, like you didn't schedule, you didn't expect that, but it happened. Let me know why you missed that. At least, within 3 days of the final exam, we can consider the makeup exam. Okay. Any questions so far? Okay, great. And academic policy, well, this is kind of like standard, no cheating in homework and test. And collaboration policy, we know that we encourage discussion. Offline discussion. And in some kind of assignments, you might discuss the details later. But when you write the homework, you should do it by yourself. That means we assume that your writing should be different. But if you still you're still worried about that, your written submissions will be identical to your partner or your friends, just state it clearly, explain explicitly in the homework submission that, like I discussed with my friend Bob, and then for problem 1, 2, 3, and we feel like we reached to some agreement, and so I feel like we might have some quite similarity in our homework solutions, but this is not cheating. It's due to our discussion. Let us know that. Otherwise we'll be considered this potential, plagiarism. That will lead to bad consequences. Okay. And finally, if you have any problems, physical challenging problems, please let me know as soon as possible. We'll try our best to help you. Okay. Thanks for your patience. We spent the whole lecture talking about all the requirements. Hopefully, that will better help you make decision, right? And also, again, any.
On the homework, it said that there are certain questions marked for graduate students. I just couldn't tell if there were any on this assignment, or just how will those be marked?
It's not too much. But there are indeed some questions mandatory for grad students, but optional for undergrad students. For undergrad students, you may receive it as a bonus question if you want to do that.
So if it's for graduate students, that's the bonus question, that's kind of how it.
If it's bonus point for grad students also, for grad students, then then the bonus will be both for graduate and undergraduate. Okay, thank you everyone, and we're gonna see you next Tuesday, and yeah.